So I just wanted to add a bit to the end of this video about dismantling one of these. This back panel is not actually designed to move at all. That stays in place. You've got two screws down here, and then you've got the couple of screws up here, and then I think there's another couple of screws somewhere else. Actually, it might just be there, and then these two at the back, and that is enough to actually get the whole unit out of the case. I don't think you have to remove anything else. This certainly doesn't need to be removed, so I've put this one back in place. And what could ultimately happen is I could just re-glue inside here, so just run some glue up along there and down there. So I don't think this is ever intended for that to actually be moved. Everything is done from the front. The whole thing comes out the front. Two screws, and I think that's your lot. Anyway, just wanted to add that on. Thank you very much for watching. So today I'm looking at something a little bit different. I'm taking a look at this rather nice Ebac 660 De-humidifier, which I think is dated around 1993. It uses, if I just flip it around, or try and flip it somewhere so I can see what it actually is using. What I can tell you about it is it uses R134 refrigerant rather than the older R12. And what it started doing at the moment is it has been running absolutely fine and obviously dehumidifying, but what it has started to do is to almost sort of make a sort of thunking noise from the compressor and actually sort of start to get quite hot. And if you happen to just sort of touch the evaporator coils, you get a weird electric shock, which is really weird. Now, I think that it is really time served and destined for the bin. But before I completely give up on it, I'm going to take the back off, and we're actually going to take a look inside of it and see if there's anything obvious that's out of place. And also do some simple little things like clean the condenser, clean the evaporator coils, and check that the fan is running correctly. So really, these are things that you can do with any dehumidifier. The more modern units, it's actually easier to clean the coils because you can actually access them pretty much almost directly through and past the filter. So what I've done in the past is if you've got the evaporator coil on the back, which is usually where the air is sucked in over, so it works basically works in the reverse way to an air conditioning unit. So air is drawn over the evaporator coil first, then blown out over the condenser coil, which warms it slightly. But the very act of running it over the evaporator coil causes any moisture in the air to condense and condense onto the evaporator, and then obviously that gets collected in a bucket inside the machine, or you can route it off in a little pipe, say a hose pipe or something along those lines. Now, this one works pretty much in the same way as a more modern unit. There's not really any sort of stark differences. The big difference is you do have this panel on the back, which is almost sort of squeezed into the case, so it makes it very difficult to get inside of it. So this is what we have. We have our compressor, and this is using R134A. We have our fan, which is moving freely, and looking at this this condenser is actually clear. So I'm going to check down here and check these earth points are connected okay, which they most definitely are. and just have a look around this compressor to see if there are any sort of suggestions of leakage. Now, if you can sort of sometimes tell with a unit like this if there is any sort of leakage of refrigerant, because what you'll tend to sort of have is little sort of oily marks around the sort of various pipes and various unions within the dehumidifier itself. It's pretty much the same as any sort of air conditioning unit. You will have potentially sort of random points where there may be sort of oil, a misting of oil in various places, which would suggest that there is a leak. Now, I can't really see any leaks around this one. I can't easily get to the front, because if you wanted to actually service this properly, or indeed to get anything out of this, it looks like this whole unit here would have to come out. And looking at it on both sides, you've got a couple of screws up in here, a couple of screws up here, and a couple of screws over there, which would then basically allow the whole assembly to come out of the unit. Now, I would be interested to do that because that would allow me to give it a proper clean, but that might prove to be a little bit more difficult than I first thought, because of the way it is actually assembled. You can sort of pretty much tell it has been assembled with non-serviceability in mind. So I'm going to disconnect the mains connection. So we have earth, neutral, live. That means I can get the mains cable out of the way. The mains cable is conveniently sort of located on this, which is quite handy. So if I did end up stripping it for parts, I could certainly keep the mains cable. I could certainly keep this fan, and to be honest with you, because it's looking at it, it's a 240 volt fan, but to be honest with you, that's pretty much all you can really keep from a dehumidifier. Everything else needs to be disposed of through the proper channels. It's not a good idea to try discharging one of these yourself, because you will just end up releasing to the environment refrigerant that actually has a higher greenhouse rating than just carbon dioxide. I don't think it necessarily affects the ozone layer in the same way that the older R12 systems did, but it's still not a particularly good thing to have released into the atmosphere. So I'm just going to try and release this a second. I should be able to hopefully just pop this off. Looking at it, it's held on, sort of clipped into place, so I might be able to do that from the other side. Just have a look. No, probably not actually. Might be able to flip it off with a flat blade. Which is easier said than done. Although not to worry, because I think I've got enough. Yeah, I've got enough clearance to get to these two screws here. pull these out. And incidentally, there is the, I guess you could call it the boiler plate, which contains the refrigerant that it's charged with and how much refrigerant it's charged with. It's charged with 0.18 kilograms of R134A. Doesn't have a year of manufacture, but looking around in various sources, 1992/93 seems to be the sort of popular figure that's coming up so far. Now I've just noticed right up the top here there appears to be a screw, which I'm wondering if that actually holds on the front panel. If I can get that off, I can actually get to that front evaporator coil and just have a look at what's going on with it. And there's another one on the other side here. There we go. And that does expose, it actually pulls the whole unit forward, but what it is exposing is a couple of top screws here, so it's actually pulling the whole of the innards of the machine forward as well. So what I should be able to do is, if I undo these top two, like so. No, that's not allowing me to separate it unless I'm missing something. However, what it does allow you to do is actually get the whole innards of the machine out from the case. That might make it a little bit easier for troubleshooting purposes. So I can get this out of the way. And I can get this back in place here. And we can have a look at what's going on. So there isn't really too much to write home about. We've got these large, I think these are resistors or fusible links, so they would tend to blow if there was a problem with the machine itself. One of them does look a bit toasty, so there does seem to be some markings on there, which does seem to suggest that it may have been running a bit warm at some point. I think all I can really do is give this a bit of a clean up. So we've got these two ribbon cables at the top here, which are going to the front panel, which is under here, which I am trying to see if I can somehow separate this. There is no filter, I've just discovered, and you can see straight to the evaporator coil, obviously through the vanes. It doesn't look like there is really sort of any extreme blockages or anything, but I will give this a bit of a clean anyway. So I'll just go and give the everything a bit of a clean now, so bear with me. So this is the thing about dehumidifier filters. Now some dehumidifiers have got sort of fancy carbon activated filters, which help to remove any sort of odours and contaminants in the air itself. Some just have bog standard filters. Now those filters are there for a reason, and one of the reasons is to obviously stop things like the coils from getting gummed up with dust and other stuff, but also to stop things like the fan motors from getting gummed up with dust, which would obviously impede their effectiveness. But also for other sort of things, such as protecting the electronics from dust. So I've given these a bit of a clean, and they do look quite a bit better. But I do wonder if there had been a filter in place, if there would have been less dust inside the unit itself. In fairness though, it looks like it's been operated in a relatively dust-free environment, because the fan blades are not caked in huge amounts of dust. You would expect to see, especially if you've got sort of a static charge going through them, you would expect to see a certain amount of dust collecting on them, and we don't seem to have that. Now what I'm going to do is to hook up the power supply. I'll need to put the water bottle back in place, so I'll just do that now. There we go. And we'll just flip it around. There we go. Then we can just plug these back in temporarily. So we had live on this side, neutral, and earth. There we are. Right, let's pop that onto max humidity, minimum fan speed. Now to me that fan is running a bit slowly, so I've got a feeling that this is getting really hot. If I pop that up to 2, it's better, but it's not perfect. So I've got a feeling that this is running very hot, and because it's running very hot, it's causing the compressor to trip. So this would point me in the direction of the fan unit itself. I mean, they're hot, and that's because there's probably resistance across this fan. So let's get this powered off. Let's disconnect all the power supplies. And what I'm going to do now is get this fan out and see if we can actually take the fan unit apart. So for that I'm going to need, I think that's an 8mm socket or spanner. Right, so we've got an 8mm socket, and I'll just whip these off quickly, making sure to keep these washers to hand. And there's 1, 2, and 2 and a bit. Well, just 2 actually. There we are. And 3. There we go. So there's number 3 there. Now I need to find a way to try and get this so I can get the fan out around this shrouding without damaging the coils themselves. And I reckon to do that, just looking at the fan, so I found the cables for the fan at the top here. So you've got the fan connectors there. And you've got, it looks like you've actually got a removable shrouding. So let me just go and fetch a flat blade. And what I should be able to do is quite literally pop these open. There we go. What this should allow me to do is to separate the shroud which seems to encompass the whole unit, to be honest with you. So separate the shroud slightly. I don't need to really separate it fully, just enough that I can move that up like so, and then that will allow me to get the fan out. Now I will probably want to take off the fan connectors at the top on the circuit board. Let's leave that hanging there for a second. So probably pop these connectors off here. There we go. And then quite literally just pop these down like so. There we go. Then same down here. So keep those out of the way, so that's your mains input. Now the fact that this has cables which are not coloured in any way suggests to me that the supply to the fan is a DC supply rather than alternating. So if we look at the power supply going in, that's our power supply, hang on a minute, brown, blue, neutral, live, earth. Yeah, there we go. That's going through this rectifier. Then that's obviously coming through the circuitry to the outputs for the fan and ultimately the compressor. And there is in here what looks like, at a guess, that's going to be a large ballast capacitor, which will obviously give enough current for the compressor to kick in, and also probably enough current for this motor as well. Although it's not a particularly high resistance motor, as you can see. I mean, it just spins. Now, it isn't particularly, it's not particularly in bad condition, bad shape. So we're going to get that one and strip it apart and see if there's anything we can do with it. So I'll move the body of the unit out of the way. And get that out of the way. There's our motor. And for a laugh, I've got a 12-volt car battery here, so Yeah, that probably needs more than 12 volts to run. So what I want to do is get the blade off itself. So we get the blade off, we'll be able to strip the motor apart and have a look at what's going on inside. So for that I need something. I think I've got the relevant item. So I've got a feeling this is a 240 volt DC motor. There's also the possibility I might be able to put a spanner on that. So I've got this 17mm spanner, which does the job. There we go, so that's that. That's quite literally that. Now we've got another two 8mm holding this together. There we go. Pulls those through. Let's keep the washers and nuts with everything. Like so. And let's have a look at how this is assembled. So we've got rid of what I think are the securing screws, but the motor itself, which doesn't spin all that freely if I'm going to be honest. Now my concern is that these rivets, these pop rivets, are actually holding the whole thing together, which means that even if we were able to separate it, it wouldn't be an easy job to repair it. Well, it wouldn't be terribly difficult, but it wouldn't be as easy as if I was just yeah, stripping it apart. Yeah, you can see here it's a 240 volts motor, 0.16 amps, so it's not exactly drawing a huge amount of energy. So we could potentially just replace the motor itself rather than sort of faffing about trying to strip this one apart. However, I've got to admit I would be interested to see if you can strip it apart, because we've got rid of those two bolts which went through, sorry, the bolts that went through here. We've got this on here which I reckon would probably twist off, but that would mean you'd have to lock the motor in place. Now actually these rivets might just be to hold the top plate and this bottom plate in place, so that's actually where the bearings are. So I might be able to potentially prise it apart. So let's see if that is indeed the case. So I want to be a little bit careful because I don't want to exactly destroy this if I can help it. But I'm just wondering if it is as simple as that. So this is where the wiring goes into. That's obviously the iron core of the motor. So it's not magnetic. So it is one of those, I think one of those phase switching motors which switches poles. which is why when I hooked it up to that direct 12-volt supply, you didn't get anything out of it, because literally you wouldn't, because of the way it's the way it is. So it does look like it is stuck together to a certain extent. So let's see. I've got a very small flat-bladed screwdriver. If there is anything I can do with that to sort of try and gently tease it apart. And my initial instincts point to probably not. No, I don't think there is, you know. I have a feeling that to fix this, it's going to need a replacement motor. Let's just see if you can actually see. No, you can see inside of there, but it doesn't really take us anywhere. So I can't get in and lubricate anything easily. What I could try is some WD-40 in the top there, see if that does anything. I doubt it will though, because if the grease has got to a point where it's quite sticky like that, and if you have the fan turned on, it's not sucking through enough air over the coils, then there's not really much else you can do. That's why we're having problems with the compressor cutting out, because it's getting too hot, so it's going into thermal overload and cutting out because there's just not enough air being drawn over over those coils. So I don't have a 240 volt motor to hand, unfortunately, unless... No, I don't think I do. So to fix this, we're going to need to purchase a 240 volt motor. But yeah, that does seem to be the problem. So I'm not going to reuse this motor. I'll just get a new 240 volt motor. But I'm interested to see if trying to squeeze in some WD-40 does improve the motor itself. So let me just see if I can hook up this nozzle to this WD-40 can, and let's go into here. There we are. So yeah, I'm not going to reuse this, but I'm interested to see if the motor does loosen up, which would further prove my theory that it is the motor that is at fault rather than the rest of the dehumidifier. But even, to be honest with you, even in sort of cases like this where you've got an extreme amount of dryness in the bearings, squirting in as much WD-40 as you want isn't going to shift. that dry grease. Yeah, I don't think that is as effective as it should be. I really don't. Let's give it another roasting with this. There we go. Right, for a laugh, I'm going to put it back in and see what it actually does. So, and also it means I don't have to find somewhere to put it whilst I'm waiting for a new one to arrive. So let's pop this back on, which is basically a vibration damper. Put this back in to place. Got a little screw or bolty thing that goes on top. Sort of like a lock nut affair. Let's say 17mm just to lock that in place. There we go. Right, let's get the rest of it up and pop it back in. There we go. Yeah, that condenser is free from dirt. That would cause compressor problems, or the compressor to overheat, rather. Right, where were we? So let's pop this in like so we can sort of split this apart slightly to tuck this into place. There's actually only one way round it will go, which is handy. There's only 3 points on it, and they have to sit into these 3 points here, so there isn't really anywhere else it can go. So I can just clip these back together. There we are. Oh, I've just remembered I need to put the motor bolts back. Oh, I'm not going to bother with that because I'm only powering it on temporarily. And I'll put probably this top one back in place. There we go. And this bottom one. Actually, I'll put all 3 of them back on, so we've got all 3 accounted for. so we know exactly where our bolts and things are. And there's one more, which is here. Don't seem to have the washer for that, so we'll have a little hunt for that in a moment. But before that, I'll just put this one, so it's there, there, and over here. Oh no, there's one already there. So we've got one more that needs to go somewhere. We've got one there, one right over here. There you go. Got little nuts here. Ooh. So little nut onto here. There we go. Let's hook this up. So it's just going to be a temporary hookup, because I'm not going to run this like this for a long period of time. I'm literally just interested to see, well, really, if it powers up, and also if we get anything out of it. So, earth, live, neutral, max dehumidification, that's improved actually. That should be, let's put it onto 2. It's hugely different actually, that's a lot different. That's running a lot faster. It's by no means perfect, but that is running a heck of a lot faster than it was. Whoop. So I'm just trying to make sure, I can feel air blowing towards me, so it's drawing air across the coils rather than blowing out the front, which it's most definitely not doing. I'm also not being electrocuted by the evaporator coils anymore, which says a lot. I'm not sure why that was happening. That is running a lot faster than it was. Now, one thing I'm not going to do is to leave it in this state with a motor that I know is not in the best shape. If I put this onto the lower speed, oh, still a lot faster than it was. And even there, it's a lot faster. So that is our next step. We need to get a new motor. We may have to adapt something more modern to fill in the space, but we can certainly give that a go. And yep, you can feel hot there. There should be cold coming out of there, which there is. That's obviously the fill point there that's been nipped off. So I would think that you would have had a fill point, well, the fill point's here, so you've obviously got one suction, one fill. And that is the That's hot, so that's going to be high pressure, I think. Or is it? I can't remember now. No, that'll be... oh, I can't remember. One of these sides is going to be cold, which I think would be the discharge from the evaporator. And then you've got the hot side here, which is going through the condenser and cooling it down so it becomes a liquid again. And then obviously it goes through the evaporator, becomes a gas. These are super hot, which I'm not sure if they should be that hot to the touch, but they are very hot. There is a possibility that that is just how they operate. But that is actually getting faster. The more I look at it, the faster that's getting. You've actually got discernible suction coming in from the front. If I put it down to a slower speed, that's still pretty fast. It's a lot better than that. You've got a nice, yeah, you've got a lot of airflow there. Compressor is pretty cool as well. That's getting faster. Isn't that interesting? That is actually getting quite a bit faster. You can actually feel the air coming off of it now, where you couldn't previously. There's a really nice blast of air coming off that. That's getting nice and warm. Those coils are getting nice and chilly. I'd go as far as to think that that's actually the speed that it should have been originally, you know. That has really improved. So, and the motor is not actually too hot at all. What I'm going to do is turn this off, put these bolts back in there just to hold the casing and the motor together, and probably top it off with some more WD-40, and I might even put it back into operation with a filter just to see how it fares, but that's a lot different than it was. That's a real improvement. I wonder if these are any cooler. No, they're still really toasty. So those are running quite hot, but and again, that is probably to be expected. And looking at them, they're probably designed to do that, to run fairly warm. So there we go. I think we have actually saved this dehumidifier. I was going to take it to the dump, but as soon as I've had this unprecedented success with it, I don't think I'm going to. What I'm going to do off camera is put it back into its case, stick on a nice carbon filter, and get a new fan ordered up for it. I think it does deserve a new fan to be installed. But that's really powered up now. That's astonishing. If I put it down to 1 again, that is so much faster than it was. You can still feel the air coming off of it. astonishing. So that just goes to show, if you do have a dehumidifier that seems to be almost sort of overheating, running too hot, and the thermal trip out keeps cutting in, don't immediately bin it. Don't immediately think that's it. Do the basics. Clean your coils. Check your fan motor. If either of those are fine, then check for leaks. You'll be able to obviously see leaks with, you'll sort of see traces of oil around the actual compressor area and on the coils themselves. But if the rest of it is checking out, then it's probably your fan motor. Anyway, I hope you have found this useful. This has certainly been a pretty good win here, because I didn't really want to get rid of this unit, because I do rather like it. It's a rather pretty looking little thing. Anyway, if you found this interesting, don't forget to hit the like button, don't forget to subscribe, and I'll see you again soon. Take care, thanks for watching.